will dive into AI and democracy. And the next keynote will be how AI is transforming defense.
So we had defense, but now we are going to talk about AI in defense and how AI is providing opportunities and challenges in defense. And we are honored to have Antoine Bordes, all the way from Spain, Vice President of AI from Helsing. So let's welcome Antoine Bordes.
Welcome.
Yeah, click with it. Thank you.
Hello, hello. Welcome, everyone. Thank you for staying. My name is Antoine. Everybody asks me how to pronounce it, so I will say it myself, Antoine Bordes, from Helsing. Helsing is a European defense company. We have presence in many countries, and we're here to try to build new technology for European democracy to defend themselves. One of the main vector we use to do this is artificial intelligence. So me, myself, by training, I am an AI researcher, an AI scientist. I've been doing that for 20 years. And today I wanted to give you a bit of a sneak peek in terms of what it means, AI in defense, and how AI is transforming defense today from our perspective. So AI can be considered right now an X factor. You hear AI everywhere. There's AI on many topics. There's a big Paris AI summit in 2 days. So this is changing many things. But I wanted to first do a bit of a look back, right? What happened in AI in the last 10 years that really got us to here? And I will tell you how it's relevant to defense as well. So the big first breakthrough that really got AI into the big curve that sits today was in 2013, with the arrival of GPUs, graphical processing units, made by NVIDIA mostly today, and they were already the case 10 years ago. GPU existed before, but around 2012, this is the first time that some students in Toronto, Montreal, and NYU in New York started to train deep neural networks on GPUs. And that was the first breakthrough that led us to here today. And I guess if you follow a bit the news, you see how much billions are invested about GPU right now. It started in 2012. You need to realize that at the time when this started to take off, what AI could do was basically giving them a picture. It needed to be a square picture. And what the AI could do was basically give you one word for it. It's called classification. And at the time, we had maybe 1,000 classes, and we could be able to say, this is a statue. Right? It's correct, this is a statue, but there are many other things. This is our door, this is in stone, etc., etc. So that was actually very limited, but that was the birth of the new era and the birth of a lot of investment in AI that flew and that speed up the improvement. Most of the investment were not done in defense. They were done in civilian AI, and most likely in California. Before joining Helsing, I've been working at Facebook for 10 years, so I know what I'm talking about. The second revolution, if you want, was 5 or 6 years later, which is called self-supervised learning. The idea of self-supervised learning is that you don't need to provide any information or data for the machine to learn. Okay? If you go back to the previous part with GPUs, to tell the machine that this is a statue, you will need to give them 100,000, tens of thousands of images with images labeled with the statue word. Say, this is a statue, this is a statue, this is a statue, this is a statue. This is working, but to some extent. And I guess if people like you are working in AI or working about AI, all about data cleaning, data annotation, getting experts to annotate the data is a big, big part of the work. It still is, but self-supervised learning made it a bit easier, right? Because what you can do is that you can fuel the machine with a lot of data that don't have any label to do what we call right now a pre-training. Pre-training, which means that the machine, after that, cannot really solve any task, but it's prepared to do it. And when you've done that, you can actually do a lot more tasks much more efficiently, much less data, etc. And so, of course, pre-training is what's done already for large language models, ChatGPT and the likes. Here, I take the example of images because it's nicer on slide, but seriously, this is a lot of the same process. Self-supervised pre-training, it was 5, 6 years ago. What you could do on an image like that without giving any information to the algorithm, you just tell them these are images, figure it out, is something like this, right? So this is called instant segmentation. But basically what you say is that, hey, machine, tell me what are the pixels that are closer to each other and that look like they belong to each other, right? That's not a task. The machine has no idea that the yellow parts are statues, the green ones are trees. It just say, this pixel cluster, they look to belong together. Okay? Of course, when you have a machine that can already do that, recognizing statues is becoming a piece of cake. Because then you can just give 5 or 6 examples about, okay, the yellow stuff, these are called statues. Now find all the statues around, and then you get much more efficient like this. So this was the second takeoff, and the combination of GPU computing and self-supervised learning unlocked the fact that you can train on web-scale data. You cannot annotate web-scale data, but you can self-supervise on web-scale data. So it worked in images, it worked in speech, it worked in text, of course, for LLMs, and it works in code as well. The last one, which is the one that really got the latest straw, but I want to go back to the first two ones are extremely important, especially in defense. So we should not forget that we talk a lot about generative AI today. In defense, a lot of what we need to do today is bring defense to the GPU and the self-supervised learning era. That's already super important. So of course, the last one, generative AI, you all know what it means, but now, of course, in the image space, you don't need to provide image to have something. You give some text and it can generate an image or a video or anything like that. This is actually pretty old. This is like 2 years ago. And now you can do way more crazy things. But this is the same trend, right? The generative AI models, they've been trained on a lot of GPUs with a lot of self-supervised learning data. Okay? And of course, now we can make crazy stuff about it. So one word on generative AI, because I'm not going to talk too much about it after. How you can use generative AI in defense, there are some usage. But if you want to go in the tactical domain and closer to the mission, generative AI is actually still not completely ready for it because of reliability and robustness issue. What you can do, and this is something we try at Helsing, is that you can use them for evaluation or testing, right? So this is not a real image. It's been generated. It's been generated by this prompt. But when you do that, you can generate some footage that can allow to say, OK, I do a drone navigation, or I do a drone detection algorithm. Will it work on this footage? Okay, and so you can generate a lot of it, and then you can basically test your different algorithm to see in conditions for which you cannot collect the data. This does not replace collecting the real data. This does not replace labeling the real data, but it can also expand the knowledge because you cannot conduct all the operation to test the algorithm in all the situations. So I think for me that's the main usage right now. It's becoming actually very big, to be clear. So now, going back to defense, why am I talking about all this and not talking about more defense specific? Well, the core of it is that military platforms are data platforms. Okay, that's really, really important. If you go on the battlefield, or if you go around in the intelligence services, there are gigantic collection of data that are being made available by sonars, by radars, by cameras, by drones, by satellite imaging, all the stuff. These are actually terabytes. The quantity of data is humongous. So the question now is who can master the data? Because who masters the data first has the advantage. If I see you before you see me, then I can make the decision to engage or not engage, but I will have an advantage for you. This advantage can be 1 hour, 1 day, 1 minute, 1 second, right? This is all that can matter depending on the situations. And so, of course, how do you master data faster and better than the enemy? Well, with better algorithm. Maybe algorithm that you train on GPU with self-supervised learning, et cetera, et cetera. That's all going back to the same story. And I think a big, big challenge now, and I heard the previous panel talking about innovation and defense and bringing names, that we need to bring all, and you guys need to bring all the technology and the advances that have been made in the civilian sector for AI into defense. Because the problems are a bit similar, but the access is way different. So there is a ton of data, but nobody has access to it. Nobody has access because it's classified, because it's complemented, because actually the storage, the usage of this data is actually not as good as you can have on the web. I mean, if you're Google and Facebook, data is your moat. Data is your gold mine. So you take a lot of care of it. When you're in the army, in the military, data is something that could be interesting, but I have other things to do before, right? So of course, but if you can harness this, you can get a lot of advantage. And clearly now, in the world we're in, this is becoming very, very important because these data sources are not something that you set to the side that is good for later. If you follow what's happening in Ukraine, the way the drones are used now to monitor almost in real time what's happening on the battlefield is extremely important. If I jam you, and so you say, I can see you and you don't see me anymore, I'm golden, right? And this is pure software. So this is getting very important. An example that we use, because this is not only about drone, right? Or this is everywhere. This is for aircraft, Air Force, right? So if you want to fly an aircraft into a dangerous zone, you need to know at any given time, and when I say at any given time, it's like at the millisecond level, what are the radars that are seeing you, okay? You have always radars seeing you. You need to know all of them. There are weather radars, civilian radars, friendly military radars, and enemy radars, of course. You need to do that at any given time, because, of course, when you detect an enemy radar that's actually doing something that's pretty nasty, like potentially like guiding a missile, you need to act on it. And you don't have 5 minutes, right? You have a few seconds, even less. So what I show on this slide is something, so you have time on the x-axis, and on the y-axis, it can be a bit confusing, is the proportion of radar signal that we can classify right now with current methods, okay? Why is it going down? It's because the radars are becoming better and better at changing their frequency, having complex patterns, so basically hiding themselves from the current methods. This is the way to go. Technology is improving, and so of course, the problem is that radars on the aircraft are pretty hard to change in the algorithm because it's the aircraft and you cannot change that easily. So if you keep going there, you will actually have the place where the aircraft will go in more environment for which they don't know if they are seen or not, or they might see that late. That's actually very problematic. The two inflection points that you see, first, explosion in number of emitters is starting like 20 years ago. You have much more radars. So then you only have, it's more like, okay, I can recognize 1 out of 10, 1 out of 100, 1 out of 1,000, 1 out of 10,000, 100,000. So even if you have the method, it starts to be harder. But the second one, which is coming right now, is agile emitters. So these are radars that can change their patterns over time as well. So the problem is getting harder, so you need more algorithm. How do you solve that? Data, AI, algorithm. How do you bring that in the aircraft and fighter jet? Super hard. But if you don't do it, it's problematic. So of course what I'm saying is, and I talked about data, is we should confirm that it's easier said than done, right? This is classical. If you go on the web and you look for, I want to learn a tank classifier, you will have an image like that. It's come from ImageNet, which is the first benchmark in AI that really got all the explosion about the statue stuff I was talking about before. This was like this. So very nice resolution. The tank is right in the center. It's beautiful. It's very easy to learn. A piece of cake for AI. When you go to real footage, you have this kind of stuff. Okay? So this is also a tank, right? This is moving. This is shaking. This isn't annotated. So there's a huge work in terms. When I say bring the technology into defense, it's not just get access and get the contract. Like you need to make it work. And usually the compute is not very good. The sensor can be very expensive or can be hard, etc. So there's a lot of work in doing that. And that's a lot of things that we try to do at Helsing right now. For the second part of this talk, of this keynote, and the end, I wanted to talk a bit about what I call now physical AI, right? What I talked before and the LLMs, etc. It's a thing about this is I would say server, and this is AI in the digital world, right? I can digitize data. But what we're moving against in defense and beyond is the bringing AI into the physical world. AI is entering the world, right? And it's not a new thing. And it's not a new thing in defense, right? So we talk a lot about drones, and there are many people talking about drones, and so you have AI algorithm embedded. This is actually headlines from 2 years ago. 2 years ago, some of the first drones that were found in Ukraine, Russian drones, they already have GPU cards. Okay? When you have a GPU, it's pretty expensive to get and hard to get for them, is because you have AI payloads on that. Right? So this is not, oh yeah, we need to put AI now in the drones. It's like 2 years ago, they're already using that. So what are they doing it right now? So it's really something about AI is already in the physical world, which means that handling different kind of data, running on batteries, being, I would say, good with hardware, etc. This is already the case. So you need now to build up good algorithm, but you need also to be able to put them in real condition very fast and very quickly. Why do I say very fast and very quickly? Because you need to work against very speed and quick competitors, right? And we are not used to that in defense, right? Traditional defense cycles, decades, right? I took the example of the Rafale plane, because I'm from France, and we're proud of our plane. It took 30 years to make it, okay? 30 years. In the 70s, you say, we need a new generation fighter. The first mission is in the 2000, right? 30 years later, okay? When you go in AI, you need to move from 30 years to 30 days. That's roughly that. If you follow the updates about what's happening on the drone space, it's basically changing every month or every quarter, right? The jamming techniques, the method, the doctrine, how you use that is changing. The effects are delivered are changing every quarter. How do you adapt a whole industry that used to work at the decade to work at the monthly basis? It's a huge challenge. It's a challenge that entrepreneurs and new companies need to take on together with the government and the primes, right? But this is a whole change of paradigm. And of course, who's able to go fast enough will be able to also bring the advantage on the battlefield, as I said at the beginning. Ukraine, for sure, is an accelerator for AI development because they need to have it, because this is a way to progress. If you want to overcome the enemy and just have a matter of months, you cannot start a new program to build a new aircraft, right? First, it's very expensive, but second of all, it will not land when you need it. But you can start a new drone development program. You can start a new jamming development program. You can start a new development by AI methods, because this could actually pay off in 3 months, right? And that's what's happening, and that's what's happening there. So, of course, they're doing it super well. Everybody else should jump on the bandwagon and on the train, because this is also what's going to drive the innovation, right? And of course, at Helsing, we are very big on this, and we are very big on trying to build the future of defense and what we call invasion deterrence, right? So now it's not about artillery, it's not about drone, it's also drone that can carry effect. The future of artillery is drone that can carry effect, strike drones. This technology was not existing at all 2 years ago. Okay, it was nowhere, right? And now it's basically mainstream on the battlefield in Ukraine. So we need to realize the change, and we need to do that. This brings a lot of opportunity for companies, for the countries. It brings also a lot of risk if you don't take the right turns. And finally, I wanted to conclude with a very old technology, electricity. Okay, so electricity is a pretty big one. So this is a paper that I really recommend from last year, 2 years ago now. And it's comparing electricity and AI and the impact on the military. And I think what's very important about that is that they show, and this paper is also looking backward in terms of the arrival of electricity in the battalion, right? Electricity was a big transforming technology, what we call general purpose technology, right? Electricity can impact many fields from communication, transportation, light, etc. And the army and the country that embrace that the faster, they build actually defensible advantage for quite some time, right? So on the left, these are all the different pathways in which you could actually put, and they use the example of the UK. Okay, you can use electricity from the first one, 1840, to actually the beginning of the First World War, right? And so you can have communications, you can have power, you can have lightning, right? So that's the example of how they've done it. And on the right, this is a comparison of electrical industrial base between UK and Russia. Russia started on electricity way later, and the penetration was actually way slower, and it gained a big advantage in terms for the UK compared to Russia in the First World War, according to this. So, of course, I encourage you to read the paper. There is a big parallel with AI today, because AI can impact communication, it can impact jamming, it can impact navigation, it can impact carrying effect, it can impact a lot of things, and there's a big barrier to adoption and porting it in on the battlefield because of the data challenge that I talked about, but also because, of course, of the challenge of robustness, assurance, quality, etc., which should not be overlooked. It's not because it's AI that you should overlook this, but it's not because it's AI that you should give up and say, oh, there's no way we can assure that, so I'm not going to look at it. It's because it's AI, it's important that you try to solve the problem of quality assurance and certification of AI algorithm. It should be solved. It will be solved, right? So will it be solved by us or by someone else, right? So that's the first and the most important point. We need to embrace AI in many parts of the defense sector. It can take small parts, big parts. It should be where it's strategic and tactical. And it should be done, I think, with a lot of conviction. And we don't have a lot of time. Thank you very much.
Thank you so much.
Thank you so much, Antoine.